Hey kids, welcome to section 3.1 Measures of Central Tendency. Today I'm going to teach you how to summarize data using measures of central tendency such as the mean, median, mode, and mid-range. So this chapter shows the statistical methods that can be used to summarize data. Measures of average are also called measures of central tendency, and they include things that you've learned before: mean, median, mode, and mid-range. The measures that determine the spread of the data values are called measures of variation. We're going to talk about those in the second section, or measures of dispersion, and they include range, which you've probably heard of, variance, which you haven't, I don't think, and standard deviation. These measures are called measures of position and include, these are another measures, and they're the third one, they include percentiles, deciles, and quartiles. So measures are found by using all the data values in the population are called parameters, and measures obtained by using the data values from samples are called statistics. So I always notice that the P in population goes with the P in parameters, and the S in samples goes with the S in statistics. So if I'm going to describe a sample, I'm going to use a statistic. If I'm going to describe a population, I'm going to use a parameter. Now, when I use that number to describe something, I have a rounding rule, and it tells me to make sure that when you're doing computations that you only round in your final answer. Don't round in the middle of a problem, because then you'll use the rounded answer to round another answer, and yeah, that's a big mess. So round once at the end. So the first measure of central tendency is called the mean. You guys might know it as the average, and that's found by adding all the values in the data together and dividing by the total number of values. Now, you've done mean since you were in elementary school, taking the average of things. And so the only thing that we're going to introduce now is the difference here between the sample mean and the population mean. The only difference in them is the notation. Notice in the sample mean, we have x bar is equal to the sum of all the x's divided by the sample size. So this E looking thing here is called the sum. So we're going to add all the x's and divide by the sample size. Notice I used x and n because in the next formula, when you're talking about population, you're going to use Greek letters. So the mean mu is equal to the sum of all the x values, this time divided by a capital N. Well, the n's mean the exact same thing, whether it's big or little, and the x bar and mu mean the exact same thing. It just depends if you're talking about a sample or a population. So in statistics, Greek letters are used to denote parameters, and Roman letters are used to denote statistics. One thing to note is that usually the mean is not an actual data value. Since you're adding and dividing, you might come up with a decimal that's not in your original data set. There is a rounding rule for the mean, and the rounding rule says that the mean should be rounded to one more decimal place than occurs in the data. So if your data that you collect is in tenths, you're going to round to one more or the nearest hundredth. So one more decimal than the data. All right, so here we have some examples on finding mean. So the first one, the number of calls that a local police department responded to for a sample of 9 months is shown. Find the mean. So in order to find the mean, I need to add all of the values up and then divide by the number of values I added. So I'm going to use, since it's a sample, I'm going to use x bar is equal to the sum of all the x values divided by the sample size n. So if I were to add up all 9 of these numbers, I would get 6,243. And the sample size is how many items were in the sample. In this case, there were 9. And so if I divide this, I get 693.7. Now, this is a descriptive statistic, so we need a descriptive word. So these are the number of calls. So we're going to put calls. And that's the mean. Okay, here's another example. The data show the number of patients in a sample of 6 hospitals who acquired an infection while hospitalized. Find the mean. Okay, so this one, it says the data is showing a number of patients in the sample. So we've got a sample. So that means that we're going to use the formula x bar is equal to the sum of all the x's divided by the sample size. So if I add up these 6 numbers right here, I get 389. There were 6 numbers. If I divide one more decimal place, I get 64.8. And these are patients. All right. You can also do the mean of a grouped frequency distribution. So remember, a frequency distribution is when you have classes and class limits, and you have boundaries and frequencies and things like that. So you don't actually know what all of the numbers are in order to find the average. We do have a way that we can estimate. It's called finding the mean for grouped data, and it involves making a table with these 4 columns, finding the midpoints of each class and placing them in column C, multiplying the frequency by the midpoint for each class and putting that product in D, finding the sum of D, dividing the sum obtained in D by the sum of the frequencies in B. Here's your formula for the mean of a grouped frequency distribution. Obviously, that means nothing until we do an example. All right, so here's an example. Use the following frequency distribution. Find the mean. The data represent the number of miles run during 1 week for a sample of 20 runners. I believe we've had this problem several times already, so we're going to find the mean. So what we're going to do is we're going to make another column here, and we're going to find the midpoint. That's x sub m. And so what we're going to do is find the midpoint of the first class. So if we add 5.5 and 10.5 together, that's 16. Divide by 2, I get a midpoint of 8. And then if I find the midpoint of the next class, I get 13. And the next midpoint is going to be 18. And then 23, 28, 33, 38. So that's step 1. Then our next column is we're going to find all the frequencies times the midpoints. So we're going to take each of the frequencies, that's this F column. We're going to multiply the 1 times the 8 and get 8. We're going to multiply 2 with 13 and get 26. 3 times 18 is 54. 5 times 23 is 115. 4 times 28 is 112. 3 times 33 is 99. And 2 times 38 is 76. Then we're going to add all of these numbers up, and you get a total of 490. Now we're ready to use our formula. The formula for the mean in a grouped frequency distribution is the sum of all the F times x sub m, the midpoints, divided by the sample size. So we have the sum of all the frequency time midpoint. That's this number right here, 490. Divided by the sample size. That's how many numbers were in the sample. Not how many classes, but how many numbers were in the sample. That's 20. If I divide this, I get 24.5 miles. Now, since you're finding the average, it should be somewhere within this table. If I got an answer like 4,500, that's way too big. If I get 100, that's way too big. But 24.5 can be found somewhere within the table, so I'm good. All right, so that's how you find mean of a grouped frequency distribution. Let's move on to the second measure of central tendency. It's called the median. The median is the halfway point in a data set. But before you can find this point, you need to make sure that you arrange the data in ascending or increasing order. It could be in decreasing order too. The point is it has to be in some kind of numerical order. When the data set is ordered, it's called a data array. And the median will either be a specific value in the data set or will fall between two values, like we're going to see. The median symbol is MD. And the procedure for finding the median, step 1, put the values in ascending order. Step 2, determine how many values are in the data set. And then step 3, depending on if it's odd or even, it's either going to be the middle data value or you're going to have to find the average of the two data values. So let's see how to do an example of a median. So here we have in the first example, the number of police officers killed in the line of duty over the last 11 years is shown. Find the median. So the first thing you have to do is put them in orders from smallest to biggest. So I have 122, then I have 141, then I have 149, 153, 155, 162, 165. Ooh, I forgot 157. Oh, okay, so we gotta go back. 157, 162, 165. It's very easy to get lost. 177, 189, 240. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers in my list. There's 11 numbers before. We're good. All right, so if we have 11 numbers, we're going to count. All right, we got this one, and then we got this one. And we got this one, and we got this one. And then this one, and this one. This one, and this one. This one, and this one. Here's the median. The median is equal to 157 police officers. All right, so that's what you do when you've got a odd number of values. Surprisingly, I have an even number. So the number of tornadoes that have occurred in the United States over an 8-year period follows. Find the median. All right, so I got to put these in order, smallest to biggest. First one is 656. The next one was 684. 702. 764. 856. 1132. 1133. And 1302. Or 1303. 1, 2, 3, 4, 5, 6, 7, 8. All right, I didn't forget any. So if I now count off one on the left, one on the right, one on the left, one on the right, one on the left, one on the right. Ooh, my answer is the average of these two. So the median is going to be to take the 764, add the 856, and divide by 2. So you're finding the average. Comes out evenly at 810, and these are tornadoes. All right, so that's how you find the median. All you got to do is put them in order, smallest to biggest, and you're good to go. Okay, the third measure of central tendency, or the third measure of averages, is called the mode. The mode's the value that occurs most often, MO, most often. It doesn't have a special abbreviation, you just write mode. Now, if a data set has only one value that occurs with the greatest frequency, it's said to be unimodal. If a data set has two values that occur with the same greatest frequency, both of those values are considered to be the mode, and the data set is said to be bimodal. If a data set has more than two values that occur with the same greatest frequency, each value is used as the mode, and the data set is said to be multimodal. But a data set could have no mode if none of the values occur more than once. So you can have one mode, unimodal, bimodals, two modes. Multimodal is more than two, or no mode. So here's some examples for how to find mode. The first example, find the mode of the signing bonuses of 8 NFL players for a specific year. The bonuses in millions of dollars are. So you can order these smallest to biggest and see which number you write more than once, or you can just kind of take a look at it and see if any numbers jump out at you. Well, I do see a 10 here, a 10 here, and a 10 here. I see 3 10s, which by far is more than any others. So therefore, the mode is equal to $10 million. Oh, I don't have to write dollars. If I look at the next one here, the data show the number of licensed nuclear reactors in the United States for a recent 15-year period. Find the mode. Well, let's see. The 111s jump out at me, but I see more 109s. I see one, I see two, three, four, five 109s. Ooh, I see 1, 2, 3, 4, 5 104s. So it looks like we have two modes here. So our modes are going to be 104 reactors and 109 reactors. Now, if one of those was 5 and the other was 4, then we'd only have one mode. Okay, finally, the number of accidental deaths due to firearms for a 6-year period is shown. Find the mode. Well, when you look at these data values, none of them repeat. So therefore, there is no mode. So you can have no mode or you can have a mode. It just depends on the problem. Now, if you don't have a list of numbers, you can find the mode using a grouped frequency distribution or just a table that includes different things and the number of them. So the mode for a grouped data is called the modal class, and that's just the class with the largest frequency. The mode is the only measure of central tendency that can be used in finding the most typical case when the data are nominal or categorical. So I would make sure that nominal or categorical data, you're going to be using the mode. So if we look at this example here, find the modal class for the frequency distribution of miles that 20 runners ran in a week. The modal class is right here. So the modal class is 20.5 to 25.5. That's called the modal class. If we look right here, the data show the number of boats registered for 6 counties in southwestern Pennsylvania. Find the mode. Well, you just got to find the one that occurs the most often. That's going to be Westmoreland. All right. One more way you can look at modes is if you have something with outliers that could influence the mean. So an extremely high or an extremely low data value in a data set can have a striking effect on the mean of the data set. These extreme values are called outliers. So we're going to take a look at this problem here, and then we're going to continue to look at it on other slides. A small company consists of the owner, the manager, the salesperson, and 2 technicians, all of whose annual salaries are listed here. Assume that this is the entire population. Find the mean, median, and mode. All right, so the mean, since this is a population, the mean is going to be mu equals the sum of all the x's over the sample size. So we're going to add up all 5 of those numbers. And when you add them up, you get 200,000. And we added 5 numbers up, 200,000. We divide it by 5, and we got 40,000. The median, MD, is the middle number. Now, these numbers are already in smallest to biggest order. So let's see, we got 18 and 100,000, 18 and 40,000. Here is our median at 24,000. Then we have the mode. The mode is the one that appears the most often. In this case, I have two 18,000s, so my mode is 18,000. Okay, so that is the third measure of central tendency, mode. We have one more measure of central tendency. It's called the mid-range. And the mid-range is a rough estimate of the middle. It's not very accurate. It's found by adding the lowest and highest values in the data set and dividing it by 2. It's a very rough estimate of the average and can be affected by one extremely high or low value. So the abbreviation for mid-range is MR, and it's found by taking the lowest and the highest values, adding them together, and dividing by 2. Now, it's a very rough estimate because it doesn't take into account any of the values in between the lowest and highest. So if we look at an example, the number of bank failures during a recent 5-year period is shown. Find the mid-range. So the mid-range is found by taking the lowest value, 3, and adding the highest value, 157. 3 plus 157. And then we divide by 2. So when I add these, I get 160 divided by 2. So I get 80, and these are bank failures. If we look at this next one, NFL signing bonuses, find the mid-range of data for the NFL signing bonuses from a previous example. The bonuses in millions of dollars are, so remember we did this one earlier to find the mode was 10. So to find the mid-range, the smallest value is 10, and the biggest value is 34.5. So to find the mid-range, we can take the lowest, 10, plus the highest, 34.5, and divide by 2. So that's 44.5 divided by 2. That's 22.25. This is in millions of dollars. So notice I know nothing, nor do I care anything about any of the values in between. All I care about is the lowest one and the highest one. Okay, now the weighted mean is not a measure of central tendency, but it does talk about the mean. And so when we have a weighted mean, we are going to have some data values that are worth more or are take up a bigger portion of whatever we're talking about. And so that type of mean is considering an additional factor, like the fact that not all of them are represented the same amount. So here we have the formula for weighted mean. We take it by adding all of the weights times the amounts and adding all of those up. Here is our formula. So you're taking all the weights, multiplying them by the data values, adding all of those up, and then dividing by all of the weights added up. Basically, if you've got some numbers that appear more than once, or if you have, especially if you're calculating a GPA, different letters are worth different point values, that's when you would use the weighted mean. So for instance, a student received an A in English Composition 1, 3 credits, a C in Introduction to Psychology, 3 credits, a B in Biology, 4 credits, and a D in Physical Education, 2 credits. Assuming that an A is 4, a B is 3, a C is 2, a D is 1, and F is 0, find the student's grade point average. So to find the grade point average, you would take each of the credits, multiply it by each of the grades, and then add them all up and divide by the total number of weights. So I can add up all my weights, 3, 6, 10, that's 12. And then I can find all of my W times X's. So I'm going to take and find my mean to be 3 times 4 plus 3 times 2 plus 4 times 3 plus 2 times 1. And then I'm going to divide that all by 12. So that gives me 12 plus 6 plus 12 plus 2 over 12. That gives me 12. That gives me 32 divided by 12. The rounding rule is one more decimal than the data, so 2.7. Okay, so this page right here now summarizes the 4 measures of central tendency: the mean, the median, the mode, and mid-range. There are some different descriptions in here, like when is it a good idea to use it? When is it not a good idea to use it? What is it? How do you compute it? And then this table over here has all of the symbols, noticing that we have Greek letters sometimes, Roman letters other times, and what the abbreviations are for some of the measures. With this, we can talk about what the distribution shape is going to look like. So there are 3 categories or types of different distributions. We have positively skewed or right skewed distributions. We have symmetric distributions and negatively skewed or left skewed. Notice that in a positive skewed or right skewed distribution, we go up and then the tail is longer. In a symmetric distribution, it goes up and then it goes down. In a negatively skewed distribution, you have the very gradual increase and then the decrease on the other side. Notice that when you are in a positively skewed distribution, that the mean is closer to the tail than the median. Notice that in a symmetric distribution, they are equal. And then notice in a negatively skewed or left skewed, the mean is on the other side of the distribution. So the mean is always closer to the tail. So in a positively skewed or right skewed distribution, the majority of the data values fall to the left of the mean and cluster at the lower end of the distribution. Right here. The tail is to the right. For example, let's get rid of this line real quick. For example, if an instructor gave an examination and most of the students did poorly, their scores would tend to cluster on the left side of the distribution. So here's all the people did really bad on the test, and a few people did really good. Another example is the incomes of the population of the United States. Most of the incomes cluster about the low end of the distribution, with those few high incomes who are in the minority on the right side. Asymmetric distribution, the data values are evenly distributed on both sides. Some examples are IQ scores, heights of adult males, anything where there's a lot in the middle and then fewer as you taper off. And then finally, when the majority of the data values fall to the right of the mean and cluster at the upper end with the tail to the left, it's said to be negatively skewed or left skewed. So notice this right here. I have a whole bunch of values on the higher end and the tail is on the lower end. An example would be if the majority of the students scored very high on an instructor's exam and a few people did poorly. All right, so let's put it all together into one big problem. The following data from several years ago represents salaries in dollars from a school district in Greenwood, South Carolina. So there are 2, 4, 6, 8, 10, 12 values there. First, assume you work for the school board in Greenwood and do not wish to raise taxes to increase salaries. Compute the mean, median, and mode and describe which one would best support your position to not raise salaries. Okay, so let's calculate the mean. So we've got to add all the values up. So we're doing the sum of all the x values divided by n. So if I were to add all 12 of these numbers up, I would get 275,000. There are 12 numbers. My mean is going to be $22,921, and it's money, so you can put two decimals. If I want to find the median, I first have to put the numbers in order from smallest to biggest. So I'm going to do that across the top. It looks like my smallest one is 10,000. And then I have an 11,000, another 11,000. They're almost in order. Then I have a 12,500. Then I have a 14,300, 16,600. Ooh, 16,400. And 16,600. And 17,500. 18,000. 19,200. And 21,560. And 107,000. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I got 12. So let's see. We got one on the left, one on the right, 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 one on the left, one on the right. We're going to be stuck in between. So I'm going to add them together and divide by 2. So we got 16,400 plus 16,600 divided by 2. That's 16,500. No. 164001666. 16,650. My bad. No. Hold on. 16,000. Why am I having a brain tooth? 16,500. Yeah, that's right. Sorry, don't mind me. Okay, then I need to find the mode. So which value appears most often? Looks like 11,000 is our mode. Okay, so then the question is, if I'm trying to convince the school board to not raise taxes, to increase salaries, which value would I use? Well, if I work for the school board and I don't want to raise salaries, then I want to show that the salary is as high as it possibly can be. So I'm going to use the mean. Use the mean to show that salaries are already high. That's the highest one out of the 3. So that would be the best one to say, hey, we don't need to raise taxes. They're already making a ton of money. Okay, well, secondly, assume you work for the teachers union and you want a raise for the teachers. Use the best measure of central tendency to support your position. Well, you could use the mode. The mode is pretty low. It's a value that's the lowest of the 3. Or you could use the median if you wanted to. Both of those are pretty low. So we could say use the median or the mode since they are the lowest values. All right, explain how outliers can be used to support one or the other position. Well, one thing you could do is recalculate the mean without the outlier. So let's just say first that the outlier is a really big number. So in this case, it's the 107,000. So if you were to calculate the mean without the outlier, so we could say without the outlier, the mean equals, so if I add up everything without the outlier, I'm going to get 168,060 divided by 11. Look at our mean now is $15,278.18. The median equals, all right, so go back. Let's pretend we take this one out. And so now we got one on this side, one on this side, one here, one there, one here, one there, one here, one there, one here, one there. Ooh, look, my median is now 16,400. And the mode is still equal to 11,000. So notice that the mean is greatly changed from 22,000 down to 15,000. The median has barely changed and the mode has not. So we can say the mean has decreased significantly when the outlier is not included. Okay, keeping going, if the salaries represented every teacher in the school district, would the averages be parameters or statistics? So if you're including every teacher in the school district, you're talking about a population, and so these would be parameters. Parameters, because the data would be part or would be, not would be part, but would be the population. Which measure of central tendency can be misleading when a data set contains outliers? And as we saw in the previous slide, the mean is most affected. And can be misleading. When you are comparing the measures of central tendency, does the distribution display any skewness? Well, how does your mean compare to your median? That's what you want to ask yourself. So my mean is the 100, the mean was 22,921.67, and the median was 16,500. And so the mean is greater than the median. And if the mean is greater, that means that the mean is going to be closer to the tail, which means the median is going to be on the left. And so it's going to be a right-tailed or positively skewed. All right, that's the end of section 3.1. If you guys have any questions, please let me know. And as always, keep calm and keep trucking.